Okay, so 2-4 says, coordinate proof using distance with quadrilateral. Okay, so what the heck does that mean? That sounds really complicated. What is coordinates? Points, right? Okay, so all we're using points, so like ordered pairs, and we're going to use the distance formula that you just learned in the last section. Okay, and we're going to prove different quadrilaterals. Okay, so what are the different quadrilaterals that we know? There's rectangles, squares, parallelograms, rhombies, or rhombuses, or trapezoids, right? Okay, so do I need to talk about different characteristics of each of those things? Or do you feel like you kind of got that, you learned that in like 4th grade or something? Pretty good so far? Okay. Okay, and everybody has the distance formula written down and starred and highlighted in their notes? Or memorized, even better. Okay. What? Not memorized yet? Okay, we'll get there. Okay, so this is a very quick example about kind of like what they asked you to do with the triangles in the last section, but now we're working with quadrilaterals, meaning 4-sided figures. Okay, so this is the same kind of scenario. They ask you to draw a rectangle this time with a length of 8 and a width of 3. Okay, so notice the 2 different ways that they drew these, and realize that are these the only 2 possible ways they could have drawn those? No. Okay, like there's technically an infinite number of ways we could draw rectangles with a length of 8 and a width of 3. Okay, depending on where we start. Okay, but I think that those 2 are by far the simplest 2 possibilities. Probably the lower one may be the simplest, right? So if they ask you to do this, maybe choose one of the simpler methods, unless you're feeling like having some fun. All right. So the next part of this is that now instead of giving you a defined number as a length, we now use a variable to represent it. Okay. So this time it says position a square. Okay, so if we're talking about a square, what do we know about squares? All sides are the same. Okay, and they want each of those sides to have a length of 2a. Okay, so now that's different than like 2. 2a is slightly, well, it's not more or less, we don't know, because a could be anything. Okay, so how could we potentially draw a square on this axis right here? How could I start? What would be super easy to do this?
Make a smaller a
One twice as long? So like, so this is like on a coordinate grid though, right? So let's say I put one of the vertices like right here, smack dab at 0, 0. Okay? And I was going to say, okay, well one side is going to be right here. See what I'm drawing right there? What is this point right here going to be? A point though. Point. An X and a Y. Okay, so this length has a length of 2a, right? So that means from 0, 0, it's going to the right 2a units. So what's my new x value? Close. That's the closest so far. 2a, 0. There you go. Okay, so 2a is the x. It goes to the right 2a, a distance of 2a, but it's not going up or down. So it still has 0 on my y coordinate. Yeah, because like if I said, let's just pretend that we're using the length of 2 instead of 2a. If it has a length of 2 and we go to the right 2 units, what's the new point? 2, 0, right? Okay. What would this point be that's directly above that has that distance of 2a? What's this point? 0, 2a. There you go. Okay. So then what's this point right out in the middle? 2a, so it goes to the right 2a and up 2a, right? So 2a, 2a. That would be more like a rectangle scenario, right? You don't think so? I think so. Okay, we're going to move past that one. Okay, so I'm not going to go through all of this, but kind of do a very quick, this is how they do it, and this is how we're going to do it scenario. What? What is it called? Drawing a square?
Without, but
And naming the vertices? Do you want to label it as something?
I don't think. Right.
How to draw a square. I don't think there was one. Alright, so what they're going to do is they're going to give you vertices. Okay, so like 4 points. And then they're going to say, alright, well, tell me what kind of shape we've got. Okay, now this one they made it a little bit nicer and they said, here's your quadrilateral and prove to me that it is a parallelogram. So you at least knew where you were going. Okay, so how can we prove that something is a parallelogram? The slopes are the same. So all you would have to do is take the slopes. Okay, so you can see that's what they did here. They found the slope of AB, and they found that slope was 3. And then they said, okay, well, AB has to be the same as CD, right? So they found that slope, and then they found 3. And then they did the same thing for BC and DA. Okay, so just by using the slopes, they could then state the fact that this is in fact a parallelogram. Okay, so that's all we are basically doing in this section. Okay, we're going to take vertices and decide what shape we've got. Okay, so here they did the same thing except for using distance, so you can use distance to make that same proof, right? Okay, so it's a 50-50. You can choose which one you like. If you prefer using slopes to make statements, or if you prefer to use the distance.
Wait, so for the distance thing, it's point to point, right? And they have to have
Right, so if we have a parallelogram, then the opposite sides would have equal length, right? And that's the same idea as being parallel, right? Just using distance instead of slope. Okay, let's go down to your turn. Let's see. There we go. Okay, so here is the big all-time question. Let's just do question number 9. Okay, and it says, we can use diagonals if we want to. So we're going to decide what kind of parallelogram this is. Whoa. So are we going to decide, we're going to have to figure out if it's a rectangle, if it's a rhombus, or if it's a square. Okay, so, well, should we talk about diagonals? It says use the diagonal, so what do we know about diagonals? Okay, so if we're talking about a parallelogram, they bisect each other. What do we know about a rhombus? They're perpendicular, so we have to talk about slopes. Yep. Yep. So then, the difference between a rectangle, a rhombus, and a square, what's the difference there? The side lengths, right? Okay, so a square all has the same length. But are they 90-degree angles or not? Right? Rhombus would not have 90-degree angles. Rhombus, perpendicular, bisect. Okay, so what should we do? Where do you guys want to start? Should we start by finding like the lengths of the sides? Should we start by finding slopes? The lengths of the sides. So we're going to decide right away if this is going to be a rectangle or a rhombus scenario. All right, here we go. So we're going to say from K to L, what would we do? What's the difference in x's?
K to L.
Can you guys see these points? So -5. can I say minus negative is the same as plus? Right? Okay, and then my y's. Wyatt, are you with me? What are my y's? Okay, you need to be with me. -1 minus 4. Okay. So how about -5 plus 2 is -3. What -3 squared is 9. So we get 9. And then -1 minus 4. -5 squared. 25. So what's 9 plus 25? So square root of 34. And I want to leave it like that. Make it simple. Now let's go LM. So what's my x's? -2 minus 3. And then my y's? So -2 minus 3 is -5. -5 squared is 25. And 4 minus 1. Joe, are we good back there? You want to come sit up by me? Or are you too distracted back there? Okay, quit talking. 4 minus 3? 4 minus 1? 3 squared? 9. So 25 plus 9? 34. So far, what do we know? So, and these are consecutive so far, right? So they're not opposite yet. MN? So from M to N, we got 3 minus 0. And 1 minus -4. So that would be 1 plus 4. Everybody okay with that? Okay, so 3 minus 0 is 3. 3 squared? 9. 1 plus 4? 5. Ooh, I feel like we're going to get another square root of 34 here. Anybody want to make a guess so far? It's a rhombus. As opposed to a square? Or that's just your guess? It's a square? Or a rhombus? Ooh. Well, that's a rhombus. A rhombus has all sides that are the same. So how are we going to decide the difference? Yeah, we got to do slope. Okay, hold on. We got to make sure the last side is the same. What? To find that all the sides are the same. Because otherwise, if we didn't, we could have been dealing with a rectangle. So we need to know the lengths and the angles. Yeah, you do. It's pretty awesome. So, -5 minus 0. How do you know? It could be a trapezoid. It could be. Well, not all trapezoids. Yeah, let's keep going. Good plan. -1. Yeah. Trapezoids are possibilities. So, how about 25 plus 9? Okay, so it did work out. You guys were right, but I just wanted to prove to you that you were right. You're welcome. Okay, so now how do I decide about the... Yes? Not right now. I'm finished talking.
Wait a second.
So now we need to talk about the slopes, right? We need to see if they're all going to be negative reciprocals, right? Okay. So here's how we're going to represent slopes with a little m in the front, a little lowercase m. So we're going to find the slope from K to L first. See what I mean by, we could do this for days and days. Okay, so what's my slope from K to L? Remember, it's changing y's over changing x's. Yep. Doesn't matter, as long as you're consistent. How about -1 minus 4 over -5 plus 2? KL. Are you looking at K and L? So the y? So -5 over -3. Agree that's 5/3. Okay, the slope from L to M. So 4 minus 1 over -2 minus 3. So far, what do we know? We got one angle they are opposite. So those two lines make a 90-degree angle, right? Well, we've only talked about one angle so far. Well, squares. Yeah, squares and rectangles have right angles. It's looking like a square. Can we stop now?
Yeah.
For sure.
Yeah.
So if we know one angle is right and all the sides are the same, we know for sure that we're dealing with a square.
Yeah. Yeah. What else? Who's a rectangle?
Rhombus.
Rhombus doesn't have
It could have one 90-degree. It's possible.
No, then it'll be equal. 90 degrees would probably be like 5. Yeah, it wouldn't be, because it has to be parallelogram. Parallel lines for a rhombus. So you know it's somewhere. Yeah. So let's just.
Well, I probably feel pretty good about a square, but I'm going to keep going because I know better and I've been tricked once or twice.
Oh my gosh.
And let's be honest, it's not that hard.
Let's be honest. It's a square.
You're still confused?
Wait, no.
Uh-oh.
What did I say? No, what the heck just happened? That's not it.
What did I do wrong?
The next one's going to be negative.
I did do it wrong. Did you see what I did wrong?
Yes.
What did I do wrong?
I don't know. If you didn't do the
Well, I did the X's over the Y's. But close.
Why did you do that?
Because you guys are distracting me.
What is that? Is that a minus here?
Yeah.
Okay, so look at this. No, I don't really know what's happening.
I'm finding the slope of all of them.
I know that, but why?
Because I have to.
Oh, weird.
Good guess.
Yeah.
I hope you don't get that guess wrong on the assignment. Okay. So what if it would have been a rhombus? What would have been different?
It wouldn't have negative 3.
It wouldn't.
Wait, what is the slope?
Right? Wouldn't. The slopes would be different, right? Right. Well, no, you would have opposite ones that are the same, but they wouldn't be negative reciprocals. So you might have like 5/3 and 5/3, but the other one might be like 3/8. You know what I'm saying? They wouldn't be negative reciprocals. But the opposite sides would still have the same.
That's good.
If there's 3/5, then like 5/3 and 3/5, they would have to be negative.
Yeah, for 3 like this.
Right. Right. Even though that would be impossible to have. But
Yeah, but
anyways, minor details. All right, so we good there? Do you guys want me to do more examples of this?
yeah.
It's pretty fun.
I think I got it. I'm pretty sure that you're integral. You need to get the homework.
Okay. No, we still have to do 2/5.
Oh.
Okay, so once again, in order for you to do this, it is not a brand new idea. It's just slightly tedious. Okay, so 2.5 is talking about perimeter. Okay, so who can tell me what the perimeter of any shape is?
All sides are
Add all the sides together. Okay, so if instead we're given a bunch of coordinates, what are we going to have to do?
count.
Coordinates? You're going to have to do distance, 4 sides, and then add the lengths together.
What do you mean?
Okay, so for example, if I went backwards and I used the one we just did, where was that one? Okay, so that's a good question, yes. Okay, so if I had this one and I had all my 4 sides and did the distance formula, I would just add the square root of 34 plus the square root of 34 plus the square root of 34. Now on today's worksheet, it lets you use a decimal. Okay, so you can add those lengths together as a decimal. Usually I don't want you to do that, but that's a little bit tedious. Yeah, it's a little ridiculous.
Wait,
Okay.
Can you add all together?
Well, that would be 4 square root of 34. You can add them together. Yeah, it would just be 4 square root of 34 and then type that in your calculator. Okay, so the second half is the area. Okay, so finding the area of a quadrilateral. Okay, I highly suggest that you write this down. I can almost guarantee that you don't know all of these.
Keep them in a little bit.
Oh, sure. Like,
Oh, that's good. Yeah, you should do the first 3. Yeah.
Oh.
What did it
This is area. Area of quadrilateral.
I'm so tired. I'm so excited to learn math. I'm gonna write all the same grade.
That's a good idea.
That's a good idea.
Is everybody writing?
Yep. I can write. So what is going?
So you're telling me that I can explain about these formulas as you write?
So far.
You can talk to me, but I can't talk to you. Okay, on the first one, that one about the area of a triangle, please tell me that's not new information.
It's not. I'm just writing it.
1/2 base times height. What's really important about that height? What is the detail?
It's the middle. If you times height times base.
Okay, but what is the height? What does the height have to be compared to the, there you go. Okay, so the height needs to be perpendicular to the base that you choose. Okay, if it is not perpendicular and you use the length of one of the sides, you're going to get the wrong answer. Okay, you have to use the height of the triangle. Okay, that's kind of like that question that we had today from the worksheet yesterday, or you know what I'm saying? Because they're different shapes. Okay, so the area of a parallelogram has that same scenario. That height must be perpendicular to the base. And they will not always give it to you, and probably mostly won't give it to you. The height must be perpendicular to the base.
How do we find it?
We'll do an example.
You can't write.
My bad. I thought you said you could. Because you actually were writing.
Yeah, but this makes it how to write.
Oh, thank God.
I know.
That is really good.
By that time, we usually just that. So talking for speaking. Right?
I feel like that's not possible.
How?
Talk, listen, and write.
That's hard. Actually, I'm gonna be very.
I feel like that's one too many things. Did you know you can only do one thing at a time and really know what you're doing?
You can like actually.
You either write or you either listen.
Wait, so like you can like. I would go over and try to talk. Like you're not behind me. Wait. Wait, did that say? I don't know. I'm trying to talk. Say whatever. Something random. Sorry, I forget.
It's hard to talk over people, isn't it? It's really annoying.
Wait. No, I do. You can talk and write at the same time, but your brain only focuses on what you have to.
Yeah, right.
So like you're only.
Yeah. Glad you could put down your pencil and tell me that. So those D's, what are those D's? D1 and D2, what are those? Diagonals. Okay, those are diagonals. If you need to tell yourself in your notes that the D is representing the diagonal, Jose, did you write this down in your notes?
Yep.
And the D stands for?
Diagonal.
Diagonal.
By the way, kids.
Apparently you can't flip quarters at the same time either.
That's so mean.
Diagonal. He says the diagonal.
What about B on the trapezoid? Okay, base. And what do the two bases have to be on the trapezoid? They have to be what? Parallel. Okay, so if that trapezoid was flipped, okay, the bases are the two sides that are parallel to each other. Okay, and then the height is perpendicular to that. Does that make sense? You want me to say it one more time? The bases of a trapezoid must be parallel. Bases, trapezoid, parallel. Heights, perpendicular. Bases, parallel. Trapezoid.
How do you know, like,
Parallel. And height is perpendicular. Height is always perpendicular no matter what shape. Alright, are we done yet?
No. Wait, no.
Yeah, and then divide by 2. Like, are you saying any other shape? Well, that's the same as multiplying by a half, right? Dividing by 2.
So, are we done?
Oh, please.
So, like, what is it?
Type in English.
And, you know how they have, like, the both these legs? Goes back, like, with the leg. Translate it. No, wouldn't that be cool?
They can do that. I'm pretty sure that's a thing. It's called Google Translate. Like it immediately translates it as you type.
Yeah, like, well, I guess like with the flag, and then you can like that. Like, I'm literally creating this. Like, I don't know how, but it's happening. Watch it. You're all listening. I'm sure there's already an app for it.
It sounds like Alright, you guys ready? So let's do one example of this finding area. Okay, so do I need to do an example of finding perimeter?
No.
Okay, you can do that. You just find the lengths and then add them all together, right? Okay, so let's talk about the area one, because the area is not exactly super simple. Although it seems super simple, it's not. Okay, so let's say they give us these 4 vertices. What do you think we should do first? Oh, sure. Okay, let's plot them. Okay, so we got -4, -2. This one is J. K is 2, 1 over here. Here's K. Sure. 3, 4 is L way over here. And -3, 1 is M. So, looking at that, what does that look like to you?
It's like a parallelogram.
Parallelogram, right? Okay, so what is the area formula for a parallelogram?
Oh,
Base times height. Okay, now does it matter which one is going to be my base?
yes.
Okay, I could use my base as MJ and then figure out what the height is straight up to LK. But I'm going to do it the other way because I think it makes more sense. Like, it seems like JK should be the base. Wouldn't you guys agree with that?
Well, yeah, because it's the bottom.
Yeah, because it's the bottom. Okay, so the first thing I need to do is make sure that this is in fact a parallelogram. Okay, I cannot just assume, because we all know what assuming makes you.
Makes it right.
Angle side side.
So,
It makes you a genius.
JK. Haha, JK. That was a good time.
Wait. I didn't think you were cheated. I want to hear it last. I didn't hear it. I didn't hear it.
Hey, if you can't pay attention, it's not my
No,
fault.
I was so excited.
Okay, so I'm going to find the distance of JK because I need that length. Okay, so J to K, what's my change in x's?
-4
-4
and then 2.
minus 2, and my change in y's?
Okay. -2 minus 1. Oh my god. Wait, get it? Yeah.
Good. So -4 minus 2 is,
-6.
and if you square -6, 36. And -2 minus 1?
-2 minus 1 is 1.
-2 minus 1 is -3. -3 squared is 9, and 36 plus 9?
Is 45.
45. Okay, and I'm going to leave it as a square root of 45 because I want to use exact measurements.
Okay.
Okay, so the next thing that I want to do is I want to find the length of ML just to verify that I do have a parallelogram. Because if it's not the same length, then I have a different issue to deal with. Okay? Yeah, then we got some other stuff to do. So, going from M to L, what's my change in x's?
M is -3.
-3 minus 3. Yep. And then
-1.
1 minus 4.
81.
What? Oh.
9.
What? 81. -3 minus 3 is -6.
I got it.
Yeah, that's when you multiply. So 36 plus 9 equals 45. Okay, so everybody okay with now I probably have a parallelogram? Probably, how do I make sure for sureness? The slope, right? So I have to check my slopes. Okay, but can I just look at this and say rise over run? So if I go from M to L, goes up 3, and I run 6. And if I go from J to K, I should go up 3 and run 6. Okay. Okay. So my base is the square root of 45. What is my height?
So divide that by 2. No. 1, 2, 3. It's not right. 2.5.
Find the distance.
Okay. So I could do that and find midpoints and go from there. Actually, that's not a bad idea. I'm going to use a technique that's going to be a little simpler, but finding the midpoints would be an exact way to do it, and that would be a really good idea. What I'm going to do here is I'm going to find the slope of JK. Okay, so we just looked at that. What is my slope from J to K? Up 3 over 6, right? So 3 over 6 is the same as 1/2. Okay, so if my height that I'm going to use is going to be perpendicular, what is the slope of the perpendicular line to my JK? So what's the slope that's perpendicular to 1/2?
-1.
Okay, what's the negative reciprocal of 1/2?
-2. I literally said that.
So -2 over 1, right? So -2. Now look at how nice that is. So let's say I start at point M. You guys see my point M? It's red.
No.
Okay, where am I going to land if I go down 2 and over 1? No.
Wait.
Down 2 over 1. No. I have to go to the right. Okay, and we're going to call this point Z.
X.
Z. What point is that?
Z.
-2, -1, -2, -1. Okay, so now I can find the distance from Z to M. That will be my height
Why
point.
did you do that? Yeah. What's that last thing?
I need to find my height. How else am I going to find the height of that?
Oh, so you go down to,
I have no idea.
oh, and then you, that's supposed to go from M, okay.
I don't remember the night
What?
view.
Is that where you have to do your slope?
What?
He's not paying.
Somewhere else.
I don't know where you're getting hypotenuse, but
Wait.
I mean there are some triangles. Okay, so
Wait.
MZ. Are you lost on why I found Z?
I just how did you find that?
How did I find MZ? Okay. So, going back. We're finding the area of a parallelogram, right? That's the very beginning. Okay, the formula for the area of a parallelogram is the base times the height. And it's important that the height happens to be perpendicular to the base. Okay, so we found the base. We're using JK as our base. So that means we need to find a height that is perpendicular to JK.
That's what this means.
Yes.
Could you use
Yeah.
K to LM? If you use LM as the base.
If I used LM, yeah.
And if you use KZ.
KZ? No, you can use KZ. So if LM is your base,
Do like K.
if ML is your base, then your height has to be perpendicular to this line.
Yeah, so
From LM.
if you do K.
Okay, cute. Yeah, so like if it landed right here, if that's the height, yeah. Yeah. Okay, so if I have to find a segment that is perpendicular to JK, I'm going to find JK slope, which is 1/2, and then figure out what would be perpendicular to that. So the perpendicular slope to 1/2 is -2. So I find a line from M or any point. I could use anything as long as it lands on my base. Okay, so I want to go down to over 1, and this point landed exactly there. Okay, so now, off of L, because it just is, if I go off of L and I go straight down, it's going to land right here. You could, yes. Okay, so how do I find the distance from M to Z? M to Z. Okay, so here's my point M and here's my point Z. So we're doing the difference in x's plus 2 minus -2, right? And 1 plus 1. What? Why? Okay. So -3 plus 2 is -1. -1 squared is 1. And then 1 plus 1 is 2. 2 squared?
4.
So I get a square root of 5. Okay, so area. Okay, so area is going to be my base times my height. What's my base length? Square root of 45. Times my height I just found to be the square root of 5. So how do I multiply that together? Sure do. That wouldn't hurt. Okay, yeah, you can multiply the inside. What's 45 times 5?
70.
70? No.
It's like
45 times 5.
150.
225, yeah. What's the square root of 225?
50. 25.
It is 15. That was a good guess. Just take it and just smile.
Did you say 50? Take the pain, get through.
Okay, we good? Should we do another example?
No, I got that.